Good morning, everybody. I'm Barry Wise, president of Eigenvector Research, and this is everything you need to know about TrendTool for exploring ordered data. And today, Scott Koch is going to help us out. And Scott, you want to go over how we do this?
Sure. Hi, everyone. Thanks for joining. We're going to record this webinar and we'll add it to our extensive list of webinars on our website.
It is extensive, isn't it?
It's getting long.
This will be number 21, I think.
As Barry mentioned, I'm Scott Koch and I'll be your moderator today. Please keep yourself muted. We generally don't use videos for ourselves and our participants to conserve a little bandwidth, so feel free to just click your video off. Post any questions in the chat, and either I or one of our staff will try and answer your question in the chat. If we feel like it's something that is better mentioned to Barry to go over, I will relay that to him. And then I think we're ready to go here, Barry.
Sounds good. Thanks, Scott. Okay, so this webinar is about TrendTool, which is a little utility that is in both PLS Toolbox and Solo. And it's really a handy tool to look at data sets with. And it's, I think, kind of underutilized. So we thought we should do something on it. So what does TrendTool do? You use it to display results of univariate calculations on multivariate data. And you can do things like show the signal at a given variable across a number of samples, say with time, or you can use it to integrate the signal across a range of variables. So you can integrate peaks, for instance. And you can also use it to show the peak position or the peak width. It'll also do some baselining, some fairly simple baselining can be done with it. And you can also use it to ratio measurements and to like add a reference uh, to it. So it's actually fairly handy. Well, where is it? Well, to open TrendTool, there's a couple of ways to do it. One of them is that it's right in the workspace browser. So if you look in your workspace browser under the analysis tools side, it by default is in your favorites. You could remove it from there if you wanted to, but it shows up there, and it also shows up under the tools menu, and so it's always going to be here under tools. So you can find it there. Or anytime you have your plot controls window open, you can take whatever data you're looking at in plot controls, and I should mention that plot controls, we also call that sometimes plot GUI is our lingo for that. So if you have the plot GUI window open, you'll see this menu that says open in, and the drop down there is to send the data into TrendTool. So you can find it there. And in the image manager, which I'm not going to look at today, you can also find an icon that'll take you directly to TrendTool from image manager. And okay, so there's two main windows when you're using TrendTool. And the first one is the data view window. And in the data view window, you look at typically the average, usually spectrum of your data. It could also be other variables, but all of our examples today are going to be using spectra. But you can look at that view and then set analysis markers. So you can set markers for features in this view and see what happens with them across the data set. You can choose the analysis mode, and I'll talk about modes here in a minute, and select references and baseline points. So just some hints here. Right click on the white space to set a marker or use a toolbar button. You can drag the markers to move them. You can right click markers to change types. And you can use the toolbar to save or load marker sets. And this is kind of a handy feature right here, is you can actually set markers in a calibration data set, so to speak, and save them to apply to new data sets. Okay, and the other window that you get when you use TrendTool is the Trend View window. So once you've specified where your markers are in your data, the results from that are displayed in trend view. So here, for instance, this feature right here in the spectrum that shows in the red bar over here in trend view did this over the course of the data set. This curve right here, this was the signal versus time for that. So your results are displayed in this trend view. For instance, the trend shown at each marker. And multiple markers show in different colors matching the data view pane. And here's just a bit about the modes. The sort of default mode is height. When you set a marker in your uh, data view, it'll then give you the response at that position. You can also change that to an area. It gives the integrated response between a pair of markers, the position, that gives the position of the peak response between markers. And that's one that I don't use too often, but and I don't have a good example of it here, so I'll just say something about it now. This is for use in the case where maybe you have peaks that shift a little bit in your data set over time, or maybe they shift because you got something that's highly overlapped. And so position actually then plots where the position of that peak is across your data set. And then width gives the full width at half max between the markers. You can do this add reference to subtract a single point baseline, or you can convert your reference to a baseline and do a 2-point linear baseline. And then normalize to region to normalize all regions to the response of a selected region. Okay, so let's do an example. And this should be a lot more obvious if we do that. So this is an oldie but a goodie. It's plasma metal etch. I say oldie but goodie because we worked with this data set when Eigenvector first started, I think in our first year or maybe our second, some 25 plus years ago now. We worked with Texas Instruments and um, Semicon on monitoring plasma metal etch in semiconductor manufacture. And when you're doing plasma metal etch of a semiconductor wafer, it typically looks like this, where what you want to do is in a chlorine and BCl3 plasma, etch off the layers of the wafer that are not covered up by the resist on top. And in this example, we've got wafers that have a little bit of titanium nitride on top, and then aluminum with a bit of copper in it, and then another titanium nitride layer and a bit more titanium, and then you're down to the oxide. So you want to put this in a plasma and etch off all this bit in between. And of course, you can actually see that happen if you're watching it with optical emission spectra. And these plasmas glow, and it's not too surprising that the elements in the plasma produce different spectra. So in the example that we're going to use, I've got optical emission spectra over the course of the etch of one of these wafers. There are 770 channels in this from 246 to 450 nanometers. Typically, there's 45 to 50 time steps. They're about 1.2 seconds each. I know it's an odd sort of spacing in time, but that was the collection speed of this system. And so we wind up with about a minute's worth of data for each one of these. And we can see the etch gas and the aluminum and the titanium. It all shows up in the OES spectra. Um, you know what? I didn't want to show that. Just a second. Where am I? Oh, I know why. Because I'm supposed to go do the demo. That's right. So here I am in the PLS workspace browser. So I've started up PLS Toolbox and I typed browse at the command window to bring up the workspace browser. If you're working in solo, of course, this is your starting window. I've loaded up a data set here that has several runs of OES data. You can find a copy of the first one of these. This one called OES1 is right here in the semiconductor etch data right there. So if you want to play with this, there's just this first one. I've got a data set with a couple more of them because I've got some other things I'm going to show. So I'm going to start with one of these data sets here, OES1, and I'm going to imagine that I wanted to do PCA on this. So I'm going to move it over here and I'm going to start it in principal components analysis. And what do we do when we're going to do a PCA? Well, we always tell people that they should look at their data first. So I'm going to click on, now that I've brought this up in PCA and it's loaded, I'm going to click on the X and I'm going to say plot data. And that comes up. And so here's my average spectrum in the OES for this. And I could click here on data in my plot controls window, my plot GUI window. And this is all the data that I have here. And again, I think this is 46 steps, something like that, of data. And I can look at this in various ways in plot control, but I started it this way specifically so I can show this. I've got the data here. It's up in plot controls. I can go from the file menu here and just say open this in TrendTool. And so I'll do that and it pops up in TrendTool. And it's a little busy right here at first. I'm going to get rid of my windows behind here just to keep things cleaned up here. Uh, okay. So when it first pops up, it actually has a tool to find peaks in here. And you can adjust the sensitivity of what it calls a peak. I'm reducing the sensitivity. And so here now you see there's a line here where every peak is. And if you want, you can start immediately by investigating at the lines that it found for peaks. I'm going to actually cancel that for now and just do this manually. So I'm going to say cancel. That'll take off the peak finder. And now we have the TrendTool data view. So again, this is our average OES spectra. And so let's set some markers and see how this works. So here is this pin right here, the push pin. If I click, it's going to add a marker to my plot. And where my marker is shows what this data does over time. Well, it just landed in the middle here. That's not a particularly interesting spot. But I can start moving it around and I can see what happens in any given spot here. And for instance, if I look at this little feature right here, I can tell that that must have something to do actually with the aluminum coming off of the wafer, because that comes off in the first 10 or 12 steps of time steps of the process, and then it goes down, flat lines to level there. So looking at that, I expect that that's probably something that has to do with aluminum in this data set. You can add another marker. And what about the big peak here? Well, the big peak here And so here, this is in red. It's this curve right here. This is from the BCl3 etch gas. And what happens with the etch gas is that it is being consumed when you're etching off aluminum or titanium. And when it's no longer being consumed, the concentration increases because it's now at the concentration of the inlet gas. So here you see it's being consumed by aluminum, it's being consumed by the titanium etch a little faster, and once that's all done, it goes back to background level here. And what else might we find in here? Well, I'd only find this because I know what to look for, but there's a little sort of bump over here. And if I look at that, and again, if I click on this and move it around, it's kind of easier to see here. I can see that this looks like maybe it has something to do with titanium etch because it has the characteristic shape of, and it's this one now here, of being of highest concentration when I think the titanium etch is going on. Okay, so this is the basic way to do this. How would I make these a little clearer? Well, let's instead do some integration of areas here. And in fact, rather than look at this aluminum, I know for a fact that these two peaks right here that I'm going back and forth over are an aluminum doublet. And in fact, when I'm on one of them right there, I can see it. And so that's this blue one right here is pretty classic aluminum. But notice here that, well, for one, I'm going to do in my system, it's a control click on this, and I'm going to change it to area. So I'm going to say area, and that splits it. So now what it does is it shows me the area in between these peaks here. And now I have this going on right here. Well, part of my problem here is that I've got baseline here on this because even when I'm all done selecting my area here, and I know I don't have any aluminum out in this region when I've etched everything off, I've got a big background on this. So one of the things that we can do, and I'm going to zoom in a bit on here, and I'm just using the roller top surface on my mouse here. So I'm going to take this and I'm going to do a control click here and say, well, add a reference. And now if I take my reference point, I can see that this is referenced to this point right here. And now I get the right shape, but it is kind of noisy. And I can take that reference now and I'll right click on it and I can change that to a baseline. So now if I take these 2 points, what I'm doing here is I'm drawing a line across the bottom from where the dotted lines intersect the line here. And so I'm really just looking at the area then under these 2 peaks. And now when I look at it, I can see that it goes high when the aluminum's first coming off, and as soon as the aluminum's done, it's pretty much near zero. It is kind of noisy still, but I think you get the drift of what I'm trying to do here. So there's a couple of ways to uh, change this. You can instead do it to the maximum at that feature. Um, you can normalize this, lots of things to do. I'm going to remove the reference for now. And I'm going to tune this up a little bit. Also here on the feature that I know is titanium, I can split that one, and I'm going to change that to an area also, so I get a little more signal in there. And backing off here, I could of course integrate my BCL3 peak as well, and I'm going to do that one as area. Okay, now what I want to do before I forget is show you that you can actually save these markers now. And so if I go to the disk here that says save markers, then I've got a thing here called TrendTool model, and it has a big timestamp on it. And I'm just going to call it though TrendTool model, and I'll say save. And now back in my browse window, that'll show up here. I've got this TrendTool model. And if I want to see how these other data sets look using those markers, all I have to do is take one of them, for instance, this OES2. I can take that, drag it onto TrendTool model, and it will then make a prediction file from that. I'm going to save it as prediction. And now if I open that data set up, here's what it's going to show me. I've got this little data set now that's the area in between all my markers, and that's my labels up on top right there, and I can plot that, and it makes more sense. In this case, I don't want to plot variables, I want to plot samples and show the data. And so this is those markers applied to a new data set, and it shows what their trend is. So that's an easy way. Then if you've got multiple ones of these and you want to look at how they all looked in time over these features, and I can imagine doing this with a set of engineering variables here too. This is spectra, but this is what we get there. Okay. How am I doing, Scott? Any questions so far or things that I'm forgetting?
We did have one question about wondering if you can ratio an area or a height of a peak of interest. For example, a chemical species that changes concentration to another peak that doesn't change, like a solid
Yeah,
peak.
you can. One way to do that is add like a single point reference here, for instance. So let me do this. I'm going to clear the markers. I'll take them all off. So I'll erase my markers. And uh, let's say that I want to do this, and I can add a reference. So add reference. So if I do that and add a single point reference, then that's taking this now reference to that. And let me see. Yeah, that was not what I wanted. And um, so in fact, that is, that's really that with that subtracted off. Now to do ratio, I think there's a way to do ratio. I don't remember what it is. Hey, Bob, if you remember that, let me know. But I tell you what, we'll look at that one. This is one way to reference it though, to that. And of course, you know, you can put that then anywhere. And reference it to, for instance, that peak right there. Okay. So I wanted to show how to get into this from another way. So we looked some at baselining, and I'm going to close this. And remember, we had our analysis window open in PCA. So I'm going to go to pre-processing here in PCA, and I'm going to edit my pre-processing. And what I want to do is use a baseline on this. And so let me show my data here. And I don't want to auto scale it. I'm going to remove that. And I'm going to instead do a weighted least squares baseline. And so I just chose that, our weighted least squares baseline here. And I'm just going to change the order of this to 4. And I just know that from having done this before that that works well on this data set. So normally that's something you have to explore, and I'll say okay. And so that applies the weighted least squares baseline to our data set. And that turned this data set right here into this because it fit a polynomial to the baseline using a weighted least squares algorithm to fit it to the bottom of the spectra. And so that took a lot of this background out, and also this wasn't on 0 either. And so it straightened all that out and put that all onto the baseline. And so I think that's okay. I like it. And remember that in the analysis window, you can always plot preprocessed data. So I can go to there, plot preprocessed data. Oops, come on, plot preprocessed data X. And so now this is what my data looks like preprocessed. Here's all the data right there. But I can open this one now in TrendTool because anytime I've got plot controls window up, I can say File, Open in TrendTool. So now I have a baselined version of my data set in TrendTool. And let's now, for instance, look at this feature right here. So now, when I look at this, there's your titanium. That's what titanium looks like when it etches off of the wafer. And when I split this here to area, I get a pretty clear signal now that it's been baselined of what titanium does here in this data set. And that's really hard to see very well unless you baseline it, because that variable baseline makes it hard to see the trend. So I just wanted to point out that you can do that. You can send your pre-processed data to the tool. Okay. I think that's all the things I wanted to cover with this. So let me get back to the presentation. If you've got any questions in the meantime, let me know.
Barry, do you want to show real quick how you would normalize to a region? Or do you want to do that at the end?
Yeah. Will you help me with that, Bob?
Certainly.
Okay. So
And you could start with your pre-processed data right there.
Okay.
And generate 2 markers, maybe one on the large peak around 270-ish.
Okay. Let me cancel that out. And okay. Here, you want me to split this to an area? Or just...
You could, that's fine.
Okay. Okay, so here I am on the large peak.
And now create a marker maybe for that doublet just shy of 400.
Okay.
And now right click on one of the red markers after you've adjusted it. And change and select normalize to region. And what you'll see is that the red trace on the right goes away because the response for that is now 1 across all the samples. So what you're doing is you're using that particular marker as an internal reference to all the other markers that you've created.
And so now,
That's a ratio.
yeah, that's a ratio of this one to that one.
Correct.
Yep.
And any other markers that you generate on this plot will then be ratioed to the red set.
Got it. So there's the ratio question answered. Okay.
We had another one come up. Can area values be exported as a table or text?
Can area values be exported? Well,
Yes.
yes. So if you have this, you can save this data right here, and you could also spawn it off into a new plot. And so, yes, these can be saved. In fact, what I just showed earlier when I had these set markers and I created the little model here, and then I opened up that prediction data set, that's what that prediction data set is. It's I did it for these areas right here, and it computed those on a new data set. You could also, of course, compute it on, just save it from your original data too. But any other thing that you did here, either these are areas, but I could have done peak position. I could have done, width at half max. Any of those would wind up in here and saved if you wanted to do that. Tell me if I'm not speaking correctly, okay, Bob and Scott.
No, that's fine.
Yeah, you can definitely save all that. Okay, so let me just clean this up a little bit. And now what I want to do is show an example here, and I don't need my PCA model anymore, and I never did make the PCA model. What I want to just show is an example with an image. So down here, we've got this wire alloy image. And actually, let me go back to my presentation and show you a little bit about it before I get going on it. So you can use trend view with images, and then the results are displayed in trend view. You can set markers on the spectra from the images, and show what's going on as an image at, say, a particular wavelength or an integrated peak from a hyperspectral image. Multiple markers will display in red, green, blue. And there's a few new toolbar buttons to use when you're doing that. There's auto scale the image, select the pixels to display. You can save or spawn. So let me introduce a data set that we'll look at here for a minute. This is energy dispersive spectrometry, or EDS. And we call this one the wires data set because these are wires of different metal alloys that are embedded in a matrix here, and you're looking at the wires end on, so they look like dots because they're a whole bunch of wires in there that are just cut off, and you're looking at the ends of them. And they're different compositions. So there's a row of them here up on top that's all nickel. The next row is 36% nickel, 64% iron, and so on. And so finally, the last one down here at the bottom is 100% copper. And in this image, a typical spectrum actually looks like this. It's pretty noisy. This is count data, and this is 1 right there. So the features in this are, pretty rough, so to speak, because the number of counts is not high. And here's the reference in this data set. But this is really pretty fun data set, as we'll see here in a minute. And we'll give you some examples here. And rather than show you too much from here, I'm going to go back to the tool. But what we're going to do is we're just going to find this wire alloy image, and we're going to drag it onto TrendTool is how we're going to get started here. So I'm going to escape out of that, get it out of here. So here's my wire alloy image. I'm going to take that and go directly here over to TrendTool. And so this wire alloy image is in PLS Toolbox and Solo. So if you want to play with this, it's right there to play with. And again, here's my automatic peak finding. I'm going to remove that and start looking around. So I know here, here's my first marker set. So as I move that, this is what the image looks like at any given wavelength in here. And for instance, I can find peaks that I'm thinking that this one right here must be the copper peak, because I see this last rows, I see only wires here that I know have copper in them. And of course, I can take that feature and split it to get a little clearer view on it, and do area here instead. And especially in data like this, that's this low count data, you're going to get a lot clearer pictures if you integrate than if you just set on one channel. Over here in the trend view, a couple things that I could do. I can show this as auto contrast. You know, that gives me a little brighter contrast in it. One thing you can also do, and this reminds me, I forgot to show the waterfall plot when I was doing the other one. You can also ask to look at this as a surface plot, which is kind of funny, really. I kind of like this. So here's what it looks like as a surface plot instead of as an image plot. So that's kind of fun. Gotta love that.
Whoa, that's a little busy.
Isn't it though? But I really like it. So anyhow, that was fun. Go back to that view. And if I set multiple markers on here, it's going to start showing these as RGB plots. So let's add another marker. And, you know, as I'm moving the marker, it's showing me just where that marker is. And so here, I think this one has to be the iron peak, if I remember correctly. And I'm going to change that into area also. And can I grab that? There we go. And so now here, this is where the challenge is, and this is something we want to change here in the future, is make the bars here match the RGBs here. So this peak though are these green ones, and the first one we set are the blue ones. And let me see, what other peak am I looking for here? I'm looking for, I want to go back to my presentation and remember what's what. So I've found the, oh, so that's the nickel peak right there. Now I'm looking for the iron peak, and the iron peak is at about 6.5. And so I'm going to go back to that one and see if I can find that here. Oh, that's this one here. Okay. So this should be iron right there. There we go. Split that. And so now you've got a red, green, blue image of things that are of those three features in your data set. And there's a few other things that you can do here. And let's see. Let me go back to my notes and remind myself of what I was going to show next. So I did this, and we showed you do that. Image exploration. There's a couple other things you can do, like the cross-section tool. And the cross-section tool, you can draw a line across your image to transect a spatial dimension. There's a drill tool and a magnification tool. And I gotta admit here, the drill tool is actually just in plot GUI, so you have to move back over there. But for the spatial tool, the cross-section tool, the trick here with it is to use the spawn results plot on the trend view. And so if I go back to my MATLAB, so I'm on trend view here. And the trick here is to use this button here that is the spawn results button. And so now I've got my results here spawned off for that. And over here, there's a button right here that is the open close image toolbar. And you need to open that in order to find this. And so if I open that, here is the tool for the cross section. And if I choose cross section, then I can go down here and, for instance, draw a line through here. And once I draw that, that shows me what it did through those points. And here I could do it again. I could choose these here. And so if I draw a line across these points, that's the values that I get here. And this is an image just of one area here. When I spawn this off, I get one at a time on this. So that was my integrated area from 7.9 to 8.22. That was this one right here, and which is my copper peak. And so you can see what it does across an image there. All right. And I think I'll dismiss that. I'm getting a little cluttered up here in terms of how many images I have. So another thing that you might do here to just explore data sets, and this is not really in TrendTool per se, is if I just take my wires data and I open that up in plot here. So this is the, I'm just making a plot of the wires data. If I change my view here to samples, then I'll get images right there. And from here, I can actually open the trend tool. So if I, or not trend tool, excuse me, but the image toolbar. And so I can do the drill down here. And if I do that, then what I am showing is any place on my image, it shows the spectra that's underneath it. And so that's the tool there. And then also anytime, I'll turn that back off. You know, you can always zoom in on these. It used to be that you had to use this or one of the tools in the toolbar to zoom. MATLAB has enabled pretty much zooming from just you know, using your mouse nowadays. So that's kind of been obsoleted.
You know, when you're using the drill tool, you can double click and put down a couple of different markers. So if you wanted to compare those
Yeah,
spots.
and I always forget that. So there, compare a few here. Just like that. Okay. Um, so that's about all I had to say today. And I think we covered all this, the drill tool and the magnification tool. You can find it right there also, but I just find it easier to just use um, the zoom that's now built into all the plots. And that works fine too. And so with that, I wanted to point to online resources here. Don't forget about the wiki. Okay. So our documentation wiki is under support right on our website, and it's searchable. And honestly, I read the documentation for TrendTool before I did this because there's a couple features in it that I don't use very often, and I forget how to use them. So I just looked, and it's just about a page or so of information that actually tells you how to do stuff. So be sure to use the wiki. Our guys have put a lot of effort into making sure that things are documented there. So it could be really very, very helpful. And then I also wanted to point out that we have a whole bunch of other webinars that we've already recorded, and this one will be recorded as well. In particular, if you're new to our software, the getting started and the importing data ones are good for those trying to get data in and get going with this. And we've got ones on principal components analysis and partial least squares regression, a really good one on cross validation. Oh, it's not plus 20 more. There's 20 altogether, plus this one now. And so with that, uh, any more questions?
Uh, yeah, there was one asking if there was a way to decompose overlapping peaks in certain data sets, and Bob, responded with MCR being, the analysis you can use to decompose data into
Right.
pure component spectra,
Yeah,
which
and
I'm sure.
this doesn't have a feature for that kind of peak fitting in it. So that's not in TrendTool, but of course curve resolution, and we have a lot of tools for that, is.
You might have some luck in some situations performing something like negative second derivative to uh, somewhat artificially enhance the resolution and be able to get responses from individual peaks, which were originally overlapped. So you would do negative second derivative pre-processing and then bring that into TrendTool.
Yeah, that might help. And that was one of the reasons that I really wanted to show how to send pre-processed data to the TrendTool. So you can use all of those tools to try to get rid of extraneous effects or to emphasize certain things, and then send that to TrendTool, and that can be a real helpful way to do things. Really help you see it. Anything else?
I don't see anything coming through.
Okay. Well, it'll take us a couple of days to get this up on the website, but when we do, we will send you a note and let you know that it's there. Let's put a copy of the slides there too, shall we, Scott?
Sounds good.
And thank you so much for joining us. We're not going to have any webinars for the next month here or so. Our guys are working on getting the next version of our software out, so we're going to focus on that. but look for a bunch of new webinars to talk about new features that are going to be in PLS Toolbox and Solo 9.0 in the near future. And hope to see you back then.